muito bleskom.
Even at them like he knows them.
No, like she was waving.
He's waving at me because waving at me because
Cool. I'm excited. It's okay. 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 Cool. I'm excited.
تيست زيدوا قربوا شويه باش ما يديرونجاش. يو كان كامير هنايا. جيو الدراري قربوا لقدام. I will be MCing in Arabic maybe. I will be MCing in Arabic maybe. Arabic maybe.
Thousand sunrises, but I'm not gonna play better. Make that gold a diamond, you got that perfect timing. I'm on the ground, but I still feel like I am fucking flying. I can feel that look in my skin, and now I'm dying. Now I'm dying again, but God, I'm trying to be a better man. There is no reason for it. I'm trying, but I can't. Just look at me.
هلو I think we will start now. Okay. Okay. So we'll start with the joke or with doing some exercise? No, I will do nothing. I will start like that. Hello. So today I'm so happy to be emceeing the first conference of React here in Morocco. But its name is React Africa, so it's the first time I think also in Africa. Maybe there is another one in Egypt, I don't know, but this is the first time in Morocco, and we will have a lot of speakers like you see today. I think we will start with Tejas, and we will have, me, yes, I will introduce myself. My name is Ayoub Alwan, I'm CTO at Servio Group, and today Ayman called me to MC this conference because he saw me, I think, in Belgium doing a conference there with a lot of jokes, but without content. And he said maybe I should give him a place to do only jokes without content, okay? So, next slide. Ayman. What Ayman? Next slide. Skin. What Ayman? Next slide, please. Skin. So, we will have our Wi-Fi. There is no password here, so you can use it. It's free. And after the conference, Ayman will send you some feedback forms that you can complete to show your feedbacks. What's Ayman? Well, Ayman, please. And we're thankful for Hayat Regency for the venue. It's like you see, it's a good quality here. Okay. And how did you find مشات لي السمية الفطور? Good. Okay. Breakfast. يلا تفكر. And we think also we have an online audience. They can see us now. After me, they will not see me. And we thank the open source community, the sponsors also, and diversity and inclusion. This is what I love about conferences. Okay. So Ayman, next slide. This is my only subject when I do conferences is diversity and inclusion. I'm really, je suis un militant pour ça. And we are thankful also for our sponsor B2 Solutions. Also, this is the company of Ayman, I think. And we thank also Jonarosoros. They are from Greece, no? سمية شوية Belgium. Giranosaurus Tex also. So we'll go to the next slide. Forkit, they are here. The guys from Forkit. We thank them. Why? Because I did my first conference there in Rouen. Chez Forkit. It was really, really nice. I did an interview with the girl there, a Tunisian girl. And also we think we are developers, Contagious Code, SkiggleConf, this week in React, Andasoft, Biztech, Soufiane Diallah. And yes, I don't know what's mean. Soufiane, tranquille? You're doing good? Happy to see you here. Allah يحفظك. React Africa, and now I think we will make some noise! And we will start with our first speaker, I think now. He's connected with us, Ayman. Ayman. Tejas is here. He's here, I think. You can hear me, Tejas, or not? Tejas, you can hear me? Tejas.
Yes, I can. Hi,
Great.
everyone.
Tejas is a great guy. I met him first time, if I remember, I think in Belgium, in other conferences, I think in Budapest, in Germany, I think. He's in Portugal, in Coimbra. So he's a great guy. He helped me a lot. And he introduced me to a lot of people there in conferences. And he wrote a book. He signed the book for me also. I think he doesn't remember that now. You remember or not? He can't hear me. Well, Ayman. So, he can't be with us now today because he has some health issues, so he can't take he couldn't take the plane to come to Casablanca, and he will do his talk today remote. So, can you test your mic, Tejas?
Yes, can you hear me, everyone?
Ayman, je pense on n'arrive pas à l'entendre. Hein.
I would love to know if you can hear me. I would love to testing. My mic. Testing. My mic. Perfect. Great. All right. I can go. Excellent.
So, I will introduce now Tejas. Come on!
Like I was ordered by a doctor not to travel, and so nothing can keep me though from being a part of this conference. I tell you what, I was at every conference, or I was involved with every conference that Ayman and Omar organized, and this is no exception. Now, I need to know if you can hear me. So the best way you can do that is to go on X or social media and just at me, mention like, "Hi Tejas, it's nice to hear from you." Okay, I'm going to share my screen, and we're going to get straight into this presentation. There will be a lot of code, and so I'm happy I have you bright and early. Let me do a quick introduction. Interesting. I can't seem to share my screen on Zoom. Ayman, if you can fix that real quick. I need permission for it. Okay, great. Now I can share. Let me share my screen, and we'll get started. Okay. So this is my screen. Let me see. Here we go. All right. This is the presentation. Let's get rid of Zoom. Hi everyone. I'm Tejas. That's pronounced like contagious. And over the years, I've had the privilege of working at a number of great companies. Today, I'm an AI engineer at DataStax, and we're going to talk about generating React Server components with AI. Okay. And so, how can we do that? Well, let's start by talking about AI and React Server components. AI and React Server components. You probably have opinions about both. If this was in person, I would ask you how many of you are using React Server components in production, and you would show me your hands. If you can't show me your hands, there's my handle here. Just go tell me on X. Okay. And so, how many of you are using server components in production? And then second, I would also ask you to show me your hands. How many of you are using AI in production? And again, just say yes or no virtually because I can't see you. In any case, there's one truth that's very important to pay attention. And that's that people are tired of AI. I personally, I'm tired of seeing AI everywhere, especially because a lot of people overpromise and underdeliver, and it's really annoying. My friend Stephanie says it very well, right? Stephanie says, "Dear brands and companies, etc., I do not want or need AI injected into every single part of my life. At this rate, I'm more likely to use your product if you're not shoving AI down my throat." And again, how many of you feel this, right? This is the vast majority of us. So AI is kind of annoying, and I want to start today's talk and really the conference by saying, look, AI is great, but I think we should use it like salt. You know, salt can add a little bit of flavor to food, but if you add too much salt, people die, you know, and AI is no, if you add AI to every single thing, you actually end up creating worse experiences than better ones. In fact, a new paper published by the University of Washington in the United States proved empirically through research that if your product mentions AI, there's less chance that people will use it. I'll share links to that on social afterwards. Okay, so now that we want to use AI properly, we want to use it as like salt instead of a full feature thing. How can we best add AI to our React apps to get the most value for our users, right? Ultimately, we're creating things for our users. We care about user experience, and we want to do user experience that's better than chatbots, okay? How can we do that? We can do that through something called generative UI, which is taking generative AI being using AI to generate stuff, text, etc., and generating UI instead. And we can do this through the magic of server components. Instead of telling you how this works, I will show you how this works. To show you how this works, I built an app, a little demo, that helps me find movies the way I like to find movies, okay? Any of you watch Netflix? Show me your hands or tell me on social media. Usually, that's the handle again. Usually, when I search for things, I don't search for the exact title or a substring of a movie, right? I'm usually in a mood and I want to watch a movie that captures my mood. I don't think in movie titles, I think in feelings. Does that make sense? And so here, let's go search Netflix the way I think, like in natural language. So if we go to Netflix, right? This is Netflix. I'm going to choose myself. And I'm just going to search like natural language. So let me do this. Let me search for movies with a strong female lead, right? And look at this. Look at this answer. It says there's no search results. Try different keywords. What does that mean? That means it expects me to search for like movie titles, not feelings. And this is really bad. In fact, look at the first suggestion, try different keywords. Now, using AI, we can do a lot better, right? We can search based on, that's the whole point of generative AI. It's good at making connections. So, using React and server components, I built an application, or I'd like to build an application that can use AI to render the results that I expect from Netflix, okay? And we're going to build this together. We're going to spend the rest of our time live coding this together, generating UI components based on AI. So to do that, let's just open our project. It's called Movies++. Let's go to localhost port 3000. It's just a Next.js app. This is what it looks like. And here's what you can see. There's a search field and there's some suggestions. When I type a query, movies with a strong female lead, nothing happens. If I click the buttons, nothing happens. And that's because this app is something we are going to create in real time. So how can we do that? Let's look at some code. I'm going to use Cursor. It's my editor of choice, but feel free to use whatever you want. So what do we have here? Let's explore the app. If we go to page or layout, actually this is a Next.js app, so layout is going to be the entry point. This is what we have. I hope you can see this. If you can't see the code clearly, tell someone, tell Amen, and he'll fix it. Okay. So here's the root layout. This, if you use Next.js, this should not be anything surprising. We have an HTML document and some children. Inside the children is going to be the page, and in the page we have main, we have our logo, which is this thing, and we have our search form. And this is all live, so if I delete the search form, you should see the search form goes away. So I'll re-add the search form. Inside the search form, we have a form, and if we should show suggestions, then show suggestions. Okay, what suggestions? Let's remove this. You can see suggestions go away. And finally, in suggestions, we have 3 suggestions, which are just hard-coded, right? Movies that feature large monsters, etc. And again, if I delete the first suggestion goes away. Okay, so this is all interactive. Let's go to suggestion now and see what happens when I click on it. When I click on it, it calls use movie search. Aha. What does that do? Well, in this case, it does literally nothing, right? And this is what we're going to fill in together. So let's just start by confirming this works. I'll alert, and now I should, okay, perfect, this works. Let's use AI here. And to start with, we're going to create a new component. It's going to be a server component. It's going to be called AI. We'll say use server. This is not actually a component. It's kind of a context, okay? And again, I hope you can hear me and I hope you can follow. If not, please make some noise, tell someone, we'll fix this. So what can we do here? We'll export const AI is the return value of create AI. And notice we're importing this from AI/RC. That's AI/React Server Components. AI comes from the Vercel AI SDK. Okay, we're going to create AI and we're going to give it some stuff. Specifically, we're going to give it some actions, which can be an empty object. These are just functions we can call. And then we start the initial AI state and the initial UI state as empty arrays. And these are arrays of conversation objects. We'll look at what that means. So now we have this AI context. Let's go to our layout and just wrap our entire application in AI like this. And again, it's just a context. So if you use React context, that's all we're doing. Great. Now our app is AI enabled. Let's make the suggestion do something. Let's make use movie search do something. For that, we need an action. Let's create an action called continue conversation. Okay? And that's all it's going to do, is it's going to continue a conversation. We're not going to get a conversation, we're going to get a message. Okay? Message, maybe string. Okay? So now, what are we going to return from this? We will return an object where it's actually a promise, but this is fine. We'll say the object's value is something. Okay, what is that something? Well, we need a response. So we'll say const data is await stream UI. This is another function that comes from the AI SDK, and it takes the following arguments. You need a large language model. In our case, we're going to use OpenAI, and we're going to use GPT-4. So I'll just import OpenAI from AI SDK OpenAI, and I'll give it the model GPT-4o. This is a really great model. It's actually one of my favorites. Do I have it? GPT-4o, perfect. Then we need some messages. Messages are exactly as they sound, like a list of messages. So we'll start with a system. Actually, we'll just leave this blank. We don't need anything for now. We just want to test that it works. And then finally, we need to respond. So if we get back text, we need to do something. And this is where the magic happens. So here we get some stuff. We get content and we get done. Let's just stick with content. And if we get content from the LLM, we're going to just return the content. So it's a basic pass-through. Now we need to return this from continued conversation. I hope this is followable so far. So we'll return the role is assistant, and the content is data.display or data.value. Okay, so we're basically just querying GPT-4o with some messages and some text. Let's go to use movie search and make this happen. So first, we'll get continue conversation. We just defined this from AI right here. So we'll get this by calling a hook use actions. Okay, we're going to get continue conversation. And now we can do some stuff. We get a prompt, right? So we can say const, we can say const conversation is, or conversation result is we continue the conversation and then we log the result. This is interesting because we need to also have the conversation state. So we'll do set conversation, and this is going to be use UI state. Okay, cool. So now what we're going to do is as soon as we get the prompt, we're going to set the conversation to be the old convo, which let's just say any, and we'll merge the old convo with my new message, which is role user and content prompt. Then we'll continue the conversation so we get the response from AI, and then we'll set the conversation again to be the old conversation with the response from AI, because we're setting the conversation a few times. This is good so far. Now let's go to our page and make it actually interactive. The result is going to come from use UI state, and everything should just work. So let's try. So we come here, and we'll say movies with a strong female lead. And now there's an error on the page. What's happening? Let's go take a look. This is totally normal. Expected okay, invalid array messages. That's fair because we're not actually doing anything. Messages is an empty array. So what we can do is say it's message. In fact, let's just add the message is role user and the content is message, just to confirm that this works, right? Because we're calling continue conversation and we're passing in a message, but we were never using it. Okay, let's try this again. Well, something's happening, but nothing's happening. This is very interesting. Let's take a quick look. I love live coding. So much can go wrong. Okay, well, we still have some issues. Let's try data.display. I think that's maybe why. Interesting. Okay. This is if you can hear me, I'm not sure, I'm not getting any feedback, but hopefully this works. So something is very wrong here. Let me check out a different branch just to make sure that this is like the full branch. And by the way, all of this is ready on GitHub for you. Okay, so yeah, let's go back to our code and return content. This looks very, very good. Okay, let's go back to page.
Incredible. Look at that. And all of this happens right here. It could be even better if you're like, where can I watch movies, right? And now it's going to show me that relative to my location, the nearest movie theater is free. And all of this from there, right? Okay, how does this work? I have 9 minutes left, so I'm going to be here. It works through the use of tools, and tools are the basis of AI agents. So if we look at tools, these are JSON objects. I'll show you one, and then you can understand how they work. Let's look at create generative UI. So a tool takes parameters, and this is a Zod schema of objects that you can give to a model. These are like, think of them as React prompts. Okay? The description is how the LLM knows when to call this function. Just like me, a human, like when you ask me to multiply a lot of numbers and read for a calculator, this description tells the LLM to call this function. What is a function? A function is just a reactive function. And so a function that returns JSX is what's going to happen. We could just generate a function. And what we do is we get a bunch of limbs, right? And we return, what do we return? We return a React component loop. Okay, what is the React component? It's literally just a div with a grid. You see, grid calls for a medium-sized string. And I control all of this. In fact, here, let's play it. And let's reload this. I'm going to say, who uses this property name? But I'm going to change my component here. I'm going to say, instead of a big poster, I'll do like H1, fastening text 6XL. Let's say React, right? I control this. I want to show it some. What might this look like? And it's going to call me my component. I just call it my component. And this component is I control this. Is that clear? So I can do whatever I want. And so of course I can return movie posters. And it's just a React component. So it's not a cost but I can do this or I can do whatever I want. And the cool thing about this is React, like the LLMs are no longer random, right? Like you can render through this as you can render anything you choose. In fact, look, we don't like using chatbots, right? I don't like, so if I'm doing customer support and I forgot my password, if I talk to a chatbot, it will tell me how to reset my password. But if I'm using generative UI, I can do something like this. I forgot my password. And it just gives me the form right here, and I fill it out, right? And it says you're all set. That is so cool, and that's the power of generative UI. And yes, it's just a tool. So remember, we wrote all this code. This is a tool called show forgot password. When the user says they forgot their password, use this tool, and the generator just returns the React component. And it can return anything. And this is the key to creating generative UI. I hope that's clear. I have 6 minutes left, so let's wrap up. We need to do UX better than chatbots. And through this code that I showed you, I hope we can do that. In some, we talked about a lot of content today, and we talked about React server components and how using the AI SDK, you can create UI, generate a bunch of tools. In fact, the tools are not generated. You just give it to them. Say, when you experience this prompt, call this function returns UI, and you have full control. The great thing is, and this is extremely important to take home with you, the LLM or the AI is not creating new components. Is that clear? It's not generating any React code. It's just returning the JSX that you write. And the best part about this is you can't run into weird cases where it makes up something dangerous. Right? Remember, I showed you I changed, let's just for posterity, let's do this again. So we'll go back to the home page. And I will generate, I won't let it generate a component, but I'll go to forgot password and I'll be like, instead of all of this, I'll just change the code to be predictable. And I'll say, hi everyone, or year one, right? And if I go here and say, I forgot my password, look at that, it's my component. This is not being generated. But you know what the LLM does generate? If we go to, it generates the prompt. So this prompt, moving from context, that's generated by the LLM, right? And that's something that is very important. Again, it brings determinism. Let's leave it there. If you have any questions, if you have anything you want to talk about on Simples, you can find me here. I want to thank you so much. Look, it's a shame that I can't fly, but I thank you for having me anyway, and I'd love to continue the conversation on any of these channels. The code for all of this is open source as
so sorry for the technical issues when Tejas started. And you know, Tejas is one. You can hear me, Tejas?
Did anyone hear him?
You can't hear nothing. Okay, so Tejas is the only guy when he's speaking, I saw people taking notes. Okay, you can talk. You can talk, Tejas. Good. You have 3 minutes left.
Yeah, I didn't know if this was the time I was staying. In any case, yeah, I'm happy to take questions.
Thank you so much, Tejas. And people can join. And now, like I said, so sorry for the technical issues. And now we will go with Matthias. He's a guy I met in, I think, in Germany. Yes, the first time in Munich. Yes, in Munich. And he, when so okay, it's your name, all that. He said, Matthias, I'm from Brazil, and I'm living in Prague. I thought that's the most random shit ever to hear. Brazilian guy in Europe, he should be in Portugal, in Spain. At what part? Yes, Brazilian guy and Brazilian, I will say. Okay. He's a great guy. Okay, and I met him the second time I came to France, in Mons. Everybody was speaking French, but him. So he was with me all time there, speaking with me English. And he excused a lot my English because I'm not that fluent like him, you will see. And I introduce you to Mathieu! Bon courage!
On peut changer d'écran pour mettre la présentation plus bien.
No, they can't, I think.
Micro.
Yeah. Oh,
It's
yeah,
okay.
that's way better. Cool. Can you hear me? Amazing. Yeah. By the way, yeah, this thing actually happened and it saved my life because the pharmacist speaking That said, thank you for having me. It's great to be here. It's my first time in Morocco. I couldn't be happier about it. Loving everything so far. And yeah, today we're going to discuss performance. So this guy Matthias from Turkey, and I'm here to present a case study of where I work. I'm a staff engineer in this company called Medallia. I'm a Google developer expert in performance, and you can find me anywhere as writing on it. Before I start, I'd like to share with you a little bit of motivation in me doing this kind of presentation. And it actually has to do with the post by the post is called and I recommend you check it out, but he starts the post by saying, while browsing offer users, sometimes get the feeling that every developer there is working for a bank, as they're always posting those doing some higher stuff. And he goes on, so that's just straight. It's like 1% of developers out there. The rest of them are just lurking and coding with a negative choice of being kind of about it. Be it sport trend or COBOL, or the reason I'm saying is what I'm about to present to you is not the latest state of technology in React or stuff or Vue. It's not about fancy rendering patterns either, or all of these nice words we have for optimizing performance these days. And by the way, you will have some sessions about this kind of whole thing. And I've had one or two about this, but I'm here to talk about optimizing performance and how some of you probably have some more, but the cliche never supposed to be one of the funny moments of the talk. But I'm here to discuss the reality of the industry and my industry performance. This company I work for, Medallia, we are in that industry, the SOC is about a process of modernizing dependencies of a legacy React code base, also introducing somewhat modern things like code splitting, React, and how to do that while targeting a very, very wide range of browsers. And the SOC is also about all of these challenges, experiences, lessons learned, and what we have else in our radar. So, first part, modernizing dependencies. Just so that you have an idea of what I'm talking about, this is somewhat where we were. So React 15, Webpack V1, and Node 10. And note, this screenshot wasn't taken 10 years ago. So starting with one of the most obvious of then, Webpack. So going from Webpack 1 to 5, you've probably seen a lot of posts out there on why Webpack 5 is great. And actually, let's be honest, a lot of days we're not even writing Webpack ourselves. We have Vite, we used to have Drake Rect app. We have a bunch of tooling that abstracts us away from writing Webpack. Still, we had a bunch of internal Webpack infrastructure, and so going to 5 was a thing, but it wasn't easy. So the first thing is you will notice that a lot of things that used to be plugins or third-party stuff, they are now part of it, or some of the things that were configured one way, they then got configured the other way. So it's just a bunch of gotchas, and I would summarize them in these 3 bullets. So the first one is that migration is about having all of the plugins and loaders in their latest versions, but also you gotta ensure they're compatible with each other. So it's not just a matter of making sure they're compatible with Webpack V5, but also that they're not colliding between them. The second thing is, and many people, myself included, don't initially realize it, you're not talking about going from V1 to V5. You're going from V1 to V2, V2 to V3, V3 to V4, and then finally to V5. And the third thing is, for example, Node.js 10 is the minimum requirement for that version for V5. But what you don't realize is that a lot of loaders and other plugins, they will have their minimum requirements. So you're not only trying to meet the expectations of Webpack, but also all the loaders. That said, upgrading Node from 10 to 16 and then to 18. The biggest challenge here, and I'm pretty sure some of you have faced it before, is Node Fibers. So Node Fibers is basically an async library that laid the foundation for a lot of work in the Node ecosystem. And after Node 14, they basically were deprecated because of internal changes in V8. And the impact this had on the whole ecosystem is enormous. And we happen to be using Sass, which under the hood was using Node Fibers. So they also have their own migration story on moving away from Node Fibers and etc. But be aware that depending on what you depend on, you might also see that when going past 14. But we're at a React conference, so let's finally talk about React and going from 15 to 16. So what a lot of people do not realize is that the core team of React, they're always doing some work across the different majors. Besides all of the performance work and stuff that they do, they also work on reducing the bundle footprint. So one example is React 15. By going from 15 to 16, you get a 30% smaller total bundle when talking about React and React DOM. And bundle size cuts were exactly the kind of things we were looking for. So we went for it. But then the first gotcha. Again, this is a Node code base, so we were using prop types, lots of it, everywhere. And the thing is, in React 15, prop types is part of the main React package, so you can just import prop types from React. But as of React 16, it was moved to a different package. So if you try to bundle that code with React 16 as a dependency, it's gonna fail because there's no prop types export there. So we needed to handle this somehow. The first thing I thought was, okay, I can use one of those node diffing libraries. I can write some diffing detection stuff and then just run a bunch of transformations. But then suddenly I realized that I just had a bunch of edge cases I didn't cover, and I was writing hundreds and hundreds of complex code. Having done some React Native in the past, I then thought, okay, I could be doing something like patch package. So if you're not familiar with patch package,
It basically allows you to define Git-based transformations, and then it applies them to your NPM dependencies. So I could use some of the internals of patch package to do something like this, but with my own code. But then, soon enough, I found myself rewriting a lot of patch package for some simple 15 to 16 migration. Then I took a step back and I found out that, okay, this is not the first time I'm going from 15 to 16. Back in the day when 16 was released, I also had to do this migration at my job at the time. And for that, one thing that helped me a lot was JS Code Shift. So who here knows JS Code Shift or has heard of or, okay, very few hands. Cool. So it's a tool by Facebook or Meta. And basically the summary is JS Code Shift is a tool that runs a transformation script over one or more JavaScript or TypeScript files. And JS Code Shift plays really well with those code mods that are called React code mods. So basically, one of them, and by the way, they're also by the React team. So one of them is called React prop types, and that is exactly what we're looking for. But they also have a bunch of other code mods that are basically transformations that you just apply to your code base to make it more modern towards something, for example, addressing APIs that were deprecated or something. So that was great. That was exactly what we're looking for, but we had a restriction. We needed to do all of that behind a feature flag because that's, even though you're not introducing any new features or major bug fixes or anything, in theory you're not changing anything. At the same time, you're changing everything because you're changing how your app is modeled. You're changing the runtime dependencies of it and etc. So if you're talking enterprise scale, you just gotta have a safe mechanism, and you gotta have some rollout strategy where customers can decide whether they want to use this new modern version or not. So that was a feature flag. And for that, we need some complex code generation infrastructure. So let's take a recap. We had to support in parallel two different versions of the developer dependencies like Webpack, Node.js, Babel, and so on, but also different versions of the app dependencies themselves, like React and React Dawn. And last but not least, different versions of all the configuration and everything around bundling and serving. So different scripts, different config files, and all of that. So this is somewhat what we had. So different packages, and let's say that package A was the core app. So all the React components, business logic, and etc. was there. And then we had a separate package for functional tests and etc. So, and so on. So we went from this to this. And breaking this down, basically, where we had legacy A is where we still had the default model that served, and all the active development went there. So if we needed to write a new feature or fix some bug and etc., we would be doing in the legacy code base. And this was, by the way, the code that was pushed to the Git repo. And this was using React 15, Webpack 1, and so on. And then we would have this Next umbrella here, but not to be confused with Next.js, which is called Next because it's the next version of that thing. And that was everything that was hidden behind a feature flag. And that's where modern dependencies went. And it was mostly composed of code transformers, automation scripts, the new config files, and whatnot. And some parts of the code that, for different reasons, we didn't manage to code generate them. And then finally, we would have the code itself that was code generated at build time, so either locally or using the CI we had. And that was a bunch of React components, utilities, and business logic coming from the legacy version. And this code, by the way, is never pushed, so we had 1,000 lines of Git code generated at the same time. So it basically looked like this, so a bunch of short tasks when you run, and just digging in a bit deeper into transformers. So if you've never played, I really recommend you check out this tool called ASC Explorer, and it helps you visualize a lot your JavaScript, JSX, or whatever code and how it gets transformed and interpreted across different declarations, literals, and all of that. So it helps you visualize the abstract syntax tree of your code. So a basic JS Code Shift transformer would look like this. So it takes some file, and then it has a lot of different APIs for you to navigate your source code. For example, all I'm doing here is I'm finding declarations of full and I'm renaming them to var, and then I'm re-exporting this new source. So that's what a hello world would look like. For our case, we had an abstraction that were different transformer groups, and these groups, they basically had a label to describe what they were doing. They had a pattern of files that they would be matching against, and they had the transformer path that would basically point to a specific JS code shift transformer. And then basically all we had to do was then iterate over those different transformer groups and apply the JS code shift transformations, be it an open source, like as in React Code Mods, or the ones that we wrote in-house. Last but not least, another thing we also had to migrate was WebDriver. So WebDriver was the tool we were using for functional end-to-end testing. And so think of it as something that allows you to write Cucumber-style feature files with gherkin syntax and then some page objects that will then run your definitions in the browser and etc. So for WebDriver, the same thing happened. So we couldn't go from 4 to 7, so 4 to 5, 5 to 6, 6 to 7, and all of that. But luckily enough, they had the same thing. So they had some code mods available out there that would go through your page objects and all different files and upgrade them. So they had one that allowed us to go from V5 to V6, transforming config files and step definitions and whatnot. And then that's it. As they said, no more changes necessary. But we found out that not really, because of Node Fibers and what we discussed back in the Node story, they also changed it internally the way how synchronicity works, and now we had to be async. So they also had a JS code shift transformation to making your code async, but it just had a bunch of edge cases that we had to manually cover. But let's call it a day for modernizing dependencies and all that, because there's other interesting topics I want to discuss. So one of them is code splitting, and you're probably thinking, okay, I've been doing it for 5 years now, great with that. So if you have not been doing code splitting or have not seen it, basically this idea that you break down your burger chunk into smaller chunks, and then you come up with some strategy to loading them based on route or based on whether that feature is needed now or later, and etc. And with React, we have a very convenient way of doing that. That is by combining React Lazy and React Suspense, both available as of React 16. And now we had 16, so we could do that. And I actually did that, and that got really good results, because then I had a bunch of chunks of questions, because we were talking about surveys. So finally, a survey taker would download only the types of questions that they are really answering, and not all sorts of possible questions a survey can have. But just like any other change, any other perf optimization thing, they don't come for free. So in our case, what I notice is, basically as a complex platform that allows our customers to write JavaScript and CSS to customize the way their surveys look, what I notice is the moment I start code splitting everything, some of the code written by our clients was expecting some DOM elements and stuff to be there, and they were not there because I was code splitting. So in that sense, we did get some regressions, and I basically needed to reduce the scope of things that I was code splitting, but still with good results. And then for free, React. So who here has heard of React or used React? Okay, like third of you. So for those who are not familiar, React is this React alternative that is way smaller than React, and like 10 times smaller, and they have React Compat, which is an official compatibility layer that basically should allow you to smoothly just start using React in your React code base. And so we did. So this is not including code splitting. So by just applying React, we cut down another good amount of kilobytes from our main bundle. And we also had gotchas. So in this case, basically what we had is we stumbled upon a lot of issues on how the elements were having a random order to be plotted to the screen. So basically, they just shifted it around intermittently. and you find out some of these issues filed on GitHub and etc. What I noticed is that in our case, it was caused by the fact that we were using Preact 10 with React Suspense and React Lazy, and apparently this is not working well. So what we did is we took one step back and we thought about how we did code splitting back in the day, and that was using loadable components. And loadable components just happened to be another 2 extra kilobytes. So we decided to experiment with the trade-off, and it was worth it. So we abandoned React Lazy and React Suspense and started using loadable components plus Preact 10, and worked like a charm. One last thing I want to talk about in terms of modernizing code bases is jQuery. So I don't have to do the raise your hands thing for this one. I'm pretty sure that a lot of you know jQuery and have used it in the past and etc. So we don't use it in this code base where we already had not been using it for quite a while now. But the thing is, so remember when I told you we allow customers to basically write custom JavaScript and custom CSS to run within our app. So it turned out that a huge number of our clients were writing jQuery to run in our platform, and that was totally out of our control because that's not our code base, technically speaking. And needless to say that jQuery at this point is not only, it might not only be a performance bump, as in it's heavy, the dumb manipulation it does is not ideal, you're loading another couple of extra kilobytes, but also they have a lot of open vulnerabilities. So overall as an ecosystem in this app, we wanted to start removing jQuery. And for that we went with a static analysis again, but this time with Bubble. Because if you want to remove something, you gotta first understand how this thing is being used. So we used a bunch of Bubble utilities like Traverse to navigate our code and detect jQuery. So overall, it looks something like this. So a bunch of things that are literally checking different expressions, different member declarations, different things like this, and trying to figure out whether that is jQuery or not. And this is super powerful because with compiler technology, we got to this kind of chart where basically we can understand not only whether a client is using jQuery, but how they're using. Because some of them are loading complex plugins, for example, but some of them are only, I don't know, doing basic HTML5, Java ES6 things that are out there. Another thing we use is proxies. So proxies, in my opinion, is one of the most underestimated things that we got with ES6. They're super powerful. And we use this to detect things in runtime. So basically using proxies, we are wrapping jQuery itself and wrapping jQuery functions so that these functions can notify us when they are involved. This way you can have your RUM technology, for example, reporting every time a live customer, hey, this function was called in runtime by a survey running here for this customer, and etc. And static analysis and compiler technologies allows us to do very, very complex things. For example, building a jQuery compiler. So this video should play. Yeah, so imagine you are just replacing some, I don't know, jQuery AJAX call with something that is a modern fetch API call. So yeah, you can write really complex things. One more thing is doing all of that and still targeting a wide range of browsers. So I don't know about you, but it's easy for us to stop to not be very mindful of what things, what kind of browsers are opening our app. For example, I was extremely surprised when I saw Blackberries or Nokia browsers or even PlayStation console browsers opening our stuff. So you do want to polyfill things to make sure that your app still works for this small amount of customers. But at the same time, you don't want to get this kind of lighthouse warning that you're over polyfilling things and etc. So you have to think about the strategies for doing this kind of thing. One of them is polyfill.io, and polyfill.io, the way it works is it basically inspects the browser user agent, and it serves a script that polyfills specifically targeting that browsers. And then you can also define a subset of polyfills you want to support using their UI, like map or something. You might be adding some extra milliseconds because you're processing something outside of your network. But the main thing is you are subject to polyfill.io outage, which actually happened. So a couple of months ago, back in summer, they got polyfill.io domain, and everyone that was using polyfill.io to basically supply polyfills had a supply chain attack. And we're talking like more than 100,000 websites. So I was glad I didn't go with it. Anyways, another thing you can do is use Babel presets. So Babel presets has two options if you've not seen it. You have use built-ins, and use built-ins has two different options. So you can do use built-ins entry, but to be honest, that's not really useful if you're targeting stuff as old as Internet Explorer 11, for example. And it might remove some polyfills, but most of them will still stay in your bottle and still be downloaded by everyone. And then the other option that is a bit more aggressive is use built-ins usage. It's not gonna add polyfills to your dependencies unless you pipe your node modules through Babel, which you might not want to do. And you might get runtime errors in your legacy browsers because this one is a more aggressive approach. And yet, it can still add some excessive polyfills. For example, if you have array.includes, it's also going to add string.includes. Or if you have symbol to string tag, it's going to add math to string tag, and etc. Because it's trying to, the way it predicts is using the method name, but it doesn't know about more other than that. And then you have something that's called differential serving. So differential serving is basically serving two different versions of your polyfills or two different versions of your app depending on some criteria. So you can easily do this by ES6 support. So if you don't have ES6 support, you don't load anything that's flagged as type no module in your scripts, and load the ones that are flagged no module. And you can use no module to serve the ES6 polyfills to the browsers that need it. So like a simplified version would look like this. So you flagged as no module, and then it's going to download everything. And then things that are flagged as module are going to be downloaded by ESX compatible browsers. And that line was fine for us to draw. So that's a recap of all of them, of the three options. So we went with module, no module, and we had to narrow down how we detected module, no module, because there's just a bunch of unexpected behaviors across different browsers. For example, we found out that some browsers are going to download both bundles and run both of them. You don't want to do that. Some browsers are going to just download both bundles, but just run one of them. And some browsers are going to download the legacy bundle and download the ES6 bundle twice. So you're making your users download even more stuff. So you don't want to do that. We thought about user agent detection then on the back end. So when the request hits our backend, we define based on the browser whether we want to serve one or the other. But the first thing is you might not be in control of your server, and that was the case. By the way, we had just a different team with different priorities, and they didn't want to add a bunch of UA detection complex logic for that. And the other thing is that if you load a modern script without the module attribute, you're losing some of the benefits you have, like string parsing and all that. So we went with runtime detection that looked something like this. So in runtime, we would check for whether you had no module support, whether no module was a thing, and module and etc. And based on that, we would download one or the other. So yeah, different ways of polyfilling. We went with module, no module, and for module, no module, we went with runtime detection. So a couple of results. We had a bunch of very, very huge PRs that are just impossible to code review and etc. And these are just two of them, but we had even more. Yet all of our unit test suites, we managed to have them passing, so hundreds and hundreds of them. In terms of model footprint, basically we had this. So for modern browsers, we had a 37% reduction, going from 280 to 177 kilobytes bundle footprint. And for legacy browsers, and that's mostly Internet Explorer, we had still a 25% smaller bundle footprint, going from 280 to 224. And basically that's where we draw the line. So modern are the ones that support ES6 modules, which as of September this year, it was almost 96% of the web, and legacy the ones that do not. And crossing this data with RUM data, this basically meant 0.2% of our customers and everyone else just getting the best version. For Web Vitals wise, we also got a bunch of improvements. So most of FCP, Speed Index, LCP, TTI, all of that improved. But not only this, so other source of timings improved. So here's a comparison with the feature flag on and off. Of course, it's not a tremendous difference, but it's some savings. And same things for visual progression of the app, feature flag on and off, you can see. A couple of things in our radar. So culture and tooling are always something. So making like a performance and being mindful of performance part of your daily job. Using tools like Bundlephobia or your having VS Code or whatever IDE you use notify you about the size of dependencies you're importing. Also using more things like Chrome developer tools, like the coverage tab that they have that gives you a lot of insights. Also, for example, experimenting with new tooling, like for example, Maven.js, they just started with a faster alternative to React, but now they're investing in very, very complex static analysis to detect possible optimizations for React with Maven Lint and now with React Scan too. Also on the back end, experimenting with more modern compression algorithms, better alternatives for compressing text, better alternatives for compressing images, and even going one step further and playing with things like Quick, which is part of the HTTP free spec, and that you can use to reduce a lot of the back and forth you have in the network when establishing connections. Now, finally, a couple of closing thoughts on this all. So I really, really believe that understanding the internals, or at least some of them, of the tools you're using will eventually help you build creative solutions, creative abstractions to complex problems. So the two examples I wanted to give you here was, for example, building a lot of the JS CodeShift-based infrastructure that goes through your code, goes through your ASC, and helps you upgrade it to more modern technologies. And the second one is, for example, using Babel to, again, go the ASC of your code, of the code of your users, and understanding what kind of things they're doing with their code. And I see an overall effort really, really moving here in terms of compilers and UI engineering, and it's not a new thing. Some of you probably remember Elm, for example. So Elm was really popular back in the day, and they did a lot of compiler-heavy code to optimize performance. And another one was PureScript that is, again, not really popular, but was doing a lot of compiler-intensive work. Then a couple of years ago, we had Prepack, for example, by Meta, and this project is no longer a thing, but Prepack was also doing a lot of static analysis for code optimization. And now we have Maven with Maven Lint and React Scan and all of that. And why not mention the frameworks themselves? So Svelte does a lot of intensive compiler work. Solid.js does a lot of intensive compiler work to optimize performance. And now we have React Forget, and that's called officially React Compiler, that started optimizing for React 19, and now it supports 17 and 18 too, and you'll hear more about it. And if you check the blog, the Satya's blog, Satya is one of the core team members working on the React compiler. You also see a bunch of very, very interesting stuff talking about all of the things we saw in computer science, taking compiler grade, and how those things can be applied to our daily basis. For example, how they're applying this to optimize the performance of our websites using the React compiler. The second thing about polyfills is, yes, you have to ship polyfills to all the browsers your users might have, but at the same time, it's also a bad idea to ship all of them that are theoretically required. So you probably need to spend some time finding the sweet spot. The cliche is true that you should not take fast CPUs or networks or RAM memory for granted. So always make sure you test on real devices and real networks. It's common to have things like this infrequently. Every year they have this infrequently noted report. So yeah, like even different kinds of connections and different kinds of devices are a thing in different countries. So be mindful of where your users are and what kind of technologies they are using. The other cliche is also true. There's no silver bullet. For example, a bunch of the things I described here would only work for us and not necessarily for other people, and the other way around. So identify your car metrics. And when you do that, always, and this is super challenging, but always try to correlate that with your business metrics. This is particularly hard to do in surveys and everything, but if you can somewhat think about bounce rates, exit rates, conversion rates, and all of that, and then match this with all the performance work, that's where you'll find the meaningful data. That's where you find the meaningful inputs. Because these metrics you cannot game. You can game lighthouse results, but you cannot game the real experience of your users. And that's pretty much all I had to present to you. You will find the slides for this presentation as well as other presentations I have on the internals of frameworks and on optimizing web performance and even on compilers here. It's been a really, really great pleasure, and I'm really hyped for the rest of the conference. Thank you for having me.
Thank you so much, Matthias, for your insightful talk. Can you do samba dance? No, or not?
Sorry?
Samba dance.
Oh no, I don't have the I don't have the chingado. That's what they call it.
What is that? Chingado?
Chingado.
C'est quoi chingado?
It's basically being able to.
Being able to do what?
Yeah, what did you said? You said
What is chingado?
yeah, it's the samba thing.
Doing that like that?
Yeah, but the right way.
I think I will dance samba better than him. So, thank you so much, Matthias, for your talk.
I don't know if we're taking questions or.
I think they will meet you in the break and they will ask you if they have questions, okay?
Yeah, looking forward. Thank you.
Thank you, Matthias. And now, we will have the queen of React Server Component here in Morocco. How I said Morocco. I'm improving my English today. I'm trying my best, Ayman. Huh? I charged only 10 dirhams of English. I will lost it, I think, in 5 minutes. So, where is Kautar? A big applause to Kautar, the best streamer girl here in Morocco, but she does streams in English. So, bon courage.
Merci. Thank you. So before we start, you may be distracted by this little cat, which is an extension called RunCat, which helped me to visualize the consumptions of CPU and memory in my Mac. So please don't focus on the cat and focus more on the presentation. Thank you. So today I will present to you React Server Components. It's a pretty new topic to the React community. And I hope that the Moroccan and African audience will understand more about this topic after my presentation. So before to start, my name is Kautar, so I'm a software engineer from Morocco, and I'm currently working in France. I'm also a public speaker. I already participated in a couple of conferences, and I've also been featured in React Conf and Next.js Conf slides. So my little picture was among the community contributors' pictures there, and it was a pleasure. And lastly, you can find me on all social media platforms under my name, including like Twitter, YouTube, or also GitHub if you want to access my code and the demo. So before we start explaining this topic, because it's a bit confusing to start explaining React Server Components, I want to do a little recap about what is client-side rendering and server-side rendering, and then we will go deeper to the server components architecture. And then I will explain the advantages, limitations, along with a quick live demo, and lastly, we will see the current state of server components. So as you may know, React is a library that will help us build UI components, and it's pretty popular among many developers in the world because it's efficient, it's modular, we can create and reuse components in multiple pages, and it's also like making the web development experience pretty smooth. So let's start with client-side rendering. What is it? So basically, when the user initiates a request by entering a URL or clicking a link, the server will respond by sending a minimal HTML file with the necessary JavaScript. The browser will then download this JavaScript and execute it to in the browser. And after that, React will take over to execute the React code in the browser. And lastly, we will render the full interactive page to the user. So this is basically the client-side rendering strategy, and it's like the default one in the traditional React. So the advantage here of client-side rendering is that it has like quick interactions after the initial load. However, the initial load might take longer, especially for large applications, because we are downloading a lot of JavaScript upfront, making our application very slow on low-end devices, especially devices with lower CPU or network usage. Now let's compare that to server-side rendering. So in server-side rendering, the user will initiate a request like before by clicking a link, and then the server will receive that request and start processing. So we will start fetching any necessary data from database or APIs, and the server will run React to generate the HTML of this data. And we will have the pre-rendered HTML sent directly to the browser, which can immediately be displayed below, as you can see. And then we will have the hydration process occurs, which is basically React will attach all the event listeners to the pre-static HTML, making the page at the end interactive. So the key difference here is that server does the initial load before doing any interactive work, and we are sending like the complete HTML to the browser, which will be static. And lastly, React will do the hydration process to make the page interactive to the user. So this approach like offers fast initial load comparing to client-side rendering, and also like it's better for SEO and search engines because they will have like output and the content of the page without waiting too much of the initial load. Now the issue was like implementing server-side rendering in plain React was not intuitive. That's why there are a lot of frameworks that have been popular to help like implement server-side rendering with React. Some of them are Next.js, Remix, Gatsby, Astro, etc. Now you might be wondering what is the relationship with these two rendering methodologies with server components. That's why I will go deeper to explain this new architecture, and at the end you will have clear visibility of the whole timeline of improvements in React. So server components, like they operate on two fundamental principles, which is like the server and client collaboration. So imagine we have like two parts, the server and the client. In the server part, which where our host, the server that hosts our code base runs, so we define on our host like our components, and then the server will try to render this content on the server, doing all the heavy stuff, and lastly on the client, which is our browser, we will only receive the final output. So previously with client-side rendering, in the browser we receive like the whole component code and render React on the browser, but now with server components we do all the execution on the server, and the browser will only receive the final output. And as you can see, even like the execution of the props which we show like hello props.name, is done on the server, and we only receive hello world, which is the final output. So this is just a sample. This is just an example that shows how like the server-client collaboration work with server components, and how we can receive on the browser just the final HTML. And what's good about like server components is that they use like familiar syntax we already know in React. So as you can see in this code snippet, like I'm doing some fetching for a blog post article. So you can see that I'm fetching like the article from a JSON placeholder like link. And then I'm just showing like at the end and returning my component, which is an article with the article title and the body. So this is a server component, by the way. And the client, which is the browser, will only receive the output, which is like the pre-established title and body and everything. So this will help us like not expose any logic or data fetching on the client, and also like the output will be optimized for the hydration process. And also like we are like doing everything on the server. So as you can see also, like because we are sending to the client like the whole HTML, we are not also sending any JavaScript. So we are just sending the output, which doesn't include any JavaScript. Now you might be wondering how this works under the hood. So I try to like break down the steps. So first we will have our component, which is a React component that you already know. This will be a server component and hosted in our server. Then when executed, we will send to the client just the final HTML output. But this is like the theory part. But under the hood, the browser will receive this JSON format, which is basically like a JSON format that represents the React tree elements, which is the virtual DOM. And of course, there are like some markers like type of to identify like React elements, and to like, they also include like the type of the HTML tag, the props and the children to help like construct the React tree. And what's good about this breakdown is that we have a separation of concerns. The server will only host our code base and execute it. The client will receive like this JSON format and translate it at the end to the HTML markup. Now to conclude, like React server components, they are exclusively executed in the server environment, and they are never executed on the client. And we only got the output at the end. So for the second point, like it highlights an important point, which is that we have control over the execution environment. So this will help us to do all the optimizations in the server, and do not worry about like the end user's device's performance, CPU or anything. And lastly, server components don't manage state because they are executed on the server. We only send the output, so we have no idea about what's happening in the browser, either like inputs, keyboard inputs or clicks or anything. Like we don't have any idea about what the user do at the browser. And I'm sure you will be wondering like what happened to all the components we all know in React, the traditional components. We can call them client components. So all the previous React you already write, we can convert them to client components because they are interactive. They may use states, hooks, keyboard inputs, clicks, event handlers, etc. And of course, to identify client components in this new architecture, we will need to add this declarative, which is useClient, in the top of your file. So to help like React identify that this component is a client component, and the other one is a server component. So the server components will be rendered on the server, and the client components, React will know using this directive that these components will also run on the browser at the end. And also, you might be wondering how a React application will look like. So this is an example of, I took from Dan Abramov blog, which Dan is core member of the React team. So he explained how modern React applications will look like. So this is basically the React tree. We will have on the parent component, which will be a server component, and then it branches out to different components, a mix of clients and server components. And of course, the developer could choose which one is server and which one is client. So now, when this tree is sent to the browser, because server components are already executed in the server, and we already know their output, they will be replaced by their HTML output, and the client components are sent like they are a module reference to their functions. So each client component is JavaScript, is a module reference to its JavaScript file, which is the component code, which will be executed on the browser. And at the end, we will have the hydration process to make all the page interactive. And this hydration process will only concern the client components. So if I need to break down like the steps one by one, we will have like, we will make a request to the server by clicking a link. The server will execute all the server components and will try to serialize their output into a JSON format as we saw. And then we will send the whole React tree to the browser. We will deconstruct each server components into their HTML elements. And then we will have, lastly, the client-side reconstruction, which the browser will receive, as I mentioned, the module reference for each client component, and will execute each one separately. And at the end, we will do the hydration process to make the whole page interactive. So a real example of that is, imagine like the blog post example I told you before. The parent component will be a server component, which is the page. And then, for example, if we have a navigation, the top bar will have like buttons to navigate, which will be a client component. Then, for example, we will have a post that we will display. This will only fetch like the post details from an API, so no interactions here. We will basically no need like for clicks or inputs. It could be a server component. Same for the comments section, but let's say if we have a like button or like a reply button or something like that, it could be like a client component, as you can see in blue, and the replies will be also like server components. So why do we need server components in our React application? First of all, like even when I explained the differences between client-side rendering and server-side rendering, we still like send some JavaScript to the client, but we didn't optimize that bundle too much. So we can see that one of the motivations behind creating server components is to reduce as much as we can the JavaScript bundle sent to the client. So we can, for example, identify in our app like all the complex components that could be rendered on the server and made them like server components, so we can reduce that JavaScript bundle. And of course, this will reduce, like, as I mentioned, when we reduce the JavaScript bundle, it makes our app fast, and this will help like our users navigate our app, especially with low-end devices. And also, like, if we are using multiple JavaScript packages and libraries, and these libraries could be also like handled in the server, we will prevent sending all the bundles of these libraries and packages we are using by doing all the heavy lifting on the server and sending just the final output to our browser. And this will contribute to reducing the download size. The second motivation made by the React team is the full access to the backend. Of course, all these motivations and advantages I'm listing here, I took them from the request for comments document that was published by the React team. So they made everything clear and open source about the motivations of React Server components. So the full access to the backend, we can explain that like by giving a seamless experience to the developers. So for example, if we want to do any API fetching or direct access to the database, why doing multiple round trips from the browser to another API sources where everything in the server? If our code is in the server, APIs are also in the server, why doing multiple round trips from the browser to the server? So we can do all the data fetching in the server itself, and the browser will only receive the final output. And also, since everything in the server, we are not exposing like any logic of our application, which is very good for, which is very bad for reverse engineers, but very good for us. And also, like, we are not exposing any API keys and sensitive data. The third motivation here is client-server waterfalls. So I want to explain this by this topic by this little schema. So imagine you have a dashboard, and in your dashboard, like, you have a list of an inbox, which is your last emails. And each email, like, you have, for example, the details of the sender. So you will need, like, basically 3 steps. The A component, which is the parent component, which is our dashboard. The B component, which is the inbox, where we are showing the last messages. And the C component, which is like responsible, for example, for fetching the user's detail. So in order to render the whole page with the client-server rendering method, we will need to wait, the parent component will need for the inbox component to finish all the fetching details, and the inbox will wait for fetching the user's details. So basically, we will face a blank screen, and we will show anything to the user until all the fetches are finished. The last one, which blocking everything, which is fetching the user's details. After that, we are like fetching the inbox details, and lastly, fetching the dashboard. Of course, I do that in the reverse order, but like you can imagine the cascading fetches. And of course, all these fetches, the last one is blocking like the first fetch, resulting to this waterfall. So since server components allow to fetch data directly on the server, we can eliminate these cascading fetches from the browser to the server by doing everything on the server. I'm not saying that the waterfall will not exist anymore, but it will be handled on the server. And we can illustrate that by having like the server section and the client section. So first of all, the client, which is our browser, will do the request to receive our page. So this is before the React Server component. The server will reply with the code of our application, which sadly contains a waterfall. So during this waterfall, we will do multiple rounds to fetch the component A. Then the server will reply with what we need for component A. But sadly, we will also need like fetches from component B and component C, so we will do multiple round trips to finally display our dashboard. But with server components, so the client will initiate the first request to the server. The server will get the code of our component, which is a waterfall, and then all the multiple round trips will be done in the server, resulting at the end getting only the output of the whole dashboard in our example. So as I said, server components do not help in eliminating this waterfall, but it helps in doing everything on the server. And since it's our server, we can control its computation speed and everything, resulting to faster initial load. Another important topic to talk about is lazy loading. So it is a technique that helps to load content only when they are needed, so rather than loading everything at once. But with traditional React, if we didn't add the lazy loading manually, it will result to a higher initial page load, and especially also the bandwidth consumption. So imagine you have 4K images in your app, and we are loading them even if the user will not see them. This is just a simple example. And to prevent that in traditional React, you will need to do the lazy imports manually one by one. So if you forget them, you are dead. But with server components, lazy loading is done automatically. So React do the automatic code splitting and lazy loading without any configuration. So this is also a very important point to highlight on the motivations of the server components. And lastly, it's the abstraction tags. So to illustrate the React abstractions, so they are basically what enable us to create reusable components and patterns. So you can see that one of the main reasons React is so popular is the reusability of its components, but this has a cost. The cost is that JavaScript engines can't and struggle to optimize these abstractions. So we can see in this funny image what these abstractions look like, and we can see that the JavaScript engines will struggle to optimize the repetitive components that are used in our application. So with server components, we will process all the abstractions in the server and eliminate this performance tax abstraction. Now, when we speak on limitations of server components, as previously said, since everything is running on the server, we have no idea about user inputs, keyboards, states, hooks, anything interactive in traditional React. And this is just a recap table I took from the Next.js doc, where it shows the use cases of server components and client components. Everything related to data fetching could be handled in the server, and everything related to interactivity could be handled on the client. So I will just show you a quick demo here, which will help us understand the topic. And of course, you can find it in my GitHub account. So this is a Next.js application. Why I'm using Next.js? Because using server components is not possible only with Next.js. And the other React frameworks are currently in progress implementing these. And also there is an unfair advantage here because some of the core members of React work also on the Next.js framework, so they are implementing the React features much faster in Next.js comparing to other frameworks. But it's just a matter of time that all React frameworks will enable the usage of server components. Okay, so as you can see, this is a Next.js app. It's the traditional one, the example I showed you before. We have a blog post here, and we are just fetching all the posts here. And when clicking on each post, we will have the comment section with a like button, which is, in our example, a counter. And then in the code, we have the home page, as you can see here, which is just fetching the whole post. And so for each for the posts pages, we are just doing the fetches from this JSON placeholder, and we are displaying the post title, body, and everything in a card, which is clickable using this link, that will take us to the /post/post ID. And we can access this route using like the Next.js file-based routing. And then on each post page, we are fetching the post again using that ID we get from the route. And we are fetching the whole comments section. So this is like just a simple application here. And we have also the comments list, which is like also getting the comments and displaying them by mapping each one. And for each comment, we are displaying the counter, which is simulating the like button here. So the first thing I want to show you that, as you can see, my whole application is using server components. And only when I need interactivity, which in this example, our counter, where we will use state, it's defined with use client. If I tend to delete the use client directive, you will see that our app will fail to load, and saying that this is a client component, and I should use client because I'm using state. Okay, another important thing I showed you before is the lazy loading. So as you can see, this is like the production application, and when scrolling to the other posts, you can see here that we are loading the components one by one using the lazy loading method, and we are getting here the JSON format I showed you before. Another important thing to mention is that client components will render on the server and the client, and server components will only render on the server. This might seem a little bit confusing, but that's because on the initial render, we will render everything in the server, resulting that also client components will be rendered just one time on the server as well. And we can see an example of this by adding like multiple console logs to our app. I will, for example, go to the comments section and add a console log here, which is, this console log should be on the server. And on the counter, I added another console log that will be shown on the client because we are on a client component. And if I just try to rebuild my app, so of course I will just go back to the home. Oh, I'm on the production app. Okay, so as you can see, this is the local app, and when refreshing the page, we will see that we will also have like the console log of the comments section, because I'm now in the single post page. So we have this console log should be in the server, which is on the comments component, and we don't see it in the client console. But when I click on a counter, you can see that it's console log, which is displaying like the output of the count is displayed on the console of the browser. But we have it also on the first initial render, also on the server. So this illustrates a bit why client components are also rendered on the server. This is just for the initial page load. Another important, I think we are out of time, but I will do things a little faster. There is another important limitation to know, which is the client component boundaries. So this is the same React tree I showed you before. Imagine we have a client component in the middle, which has use client. So when this component will re-render, we will create a client boundary, making all the children components also clients. So let's try to illustrate that in our application to understand more. I will just create a label component here. So I'm just like returning a paragraph of count. And yeah, closing this. And then I will import this component here. And I'm doing a console log here to see this. Okay. So basically what happened here is that I'm using this label component, which is supposed to be a server component, because we have nothing special here. And I'm doing like a console log here to see if this log will display on the server or on the client. And then I'm just importing my label component, which is a server component in a client component. So as you can see, like the console log is displayed on the browser. However, this is a server component. So this is a problem explaining these client boundaries. So to prevent this, there is a limitation concerning the imports of server components. So we should not like import our server components directly in our client component, because it will result to making this server component a client component. Instead, we should pass this component as a children or prop. So this is also one of the limitations of server components, and obviously this is a workaround. And why this happened? Because when the component is passed as prop or children, it will prevent re-rendering the component, which we want because it's a server component. We already have the output. Why would we bother ourselves to re-render a server component each time the parent updates? So we can like fix that very easily, or I will just like I will declare here like props, so which is our label, which will be React, not React node element. And then I will delete this like that, and I will display my label like that. And so we are passing now the label as a prop. Let me just click this. So I defined a prop in our counter, which will take the label component, and in the where I'm using my my counter, I will just call this label, which will be the component label. Now I need just to import it. So as you can see, like if I refresh the page, we will no longer see like the console logs of the label, and they are now present on the server. So of course, this is just a workaround to know how things works in server components with parent-client components. Lastly, I want to talk like about the difference between server-side rendering and server components. So instead of focusing on the first word, which is server, which might be confusing, please try to focus on the last word, which is rendering and components. So basically, like server-side rendering is primarily about rendering the initial page on the server, sending the whole HTML page to the client. But server components are concerning the rendering of each component itself. So when we have like specific updates on our UI, we can just render that specific server component if we want, instead of the whole page. And lastly, like server-side rendering will still require JavaScript, but server components will not need JavaScript because we are sending the plain HTML to the browser. Now, lastly, I want to finish, and sorry for the time, about like the current state of server components. So as you might see, there is a layer of complexity. There are some import limitations, and there are also like limitations on all the client stuff we are used to do, especially like states, hooks, event listeners. So we should like understand well the separations of concerns between what the client is supposed to do and what the server is supposed to do to understand this whole architecture. Also, there are already some packages using server components, like, for example, Tailwind, Storyblock, Content Layer. The list is not exhaustive. And when you use like one of these packages that support server components, what it means that you don't need to, the JavaScript of these packages will not be sent to the browser. But if the package does not support yet like server components, for example, Material UI or React Query, you will need to use client's directive each time you are using this package. And lastly, when it comes to Remix, they are still working on React Server Components compatibility. And also, there is this important talk at React Conference, which is bringing server components to mobile side. I highly recommend to see this talk, which is available in YouTube. And it also like shows the future of server components on the mobile side. And lastly, with server components, we can do all the backend stuff in React. We can say that React is full stack, and I don't know if it's a good thing or bad thing. It's pretty opinionated. That's it for me, thank you. And I will be in the lobby for if you have any questions.
Thank you so much, Kautar. And now we will have what? We'll have a break for 15 minutes, so you can go there and eat if you want, drink if you want. Mais I think I will take pain au chocolat. فيا الجوع un petit peu. Je vais faire mon mieux. Bon, يلا يلا نمشيو ناكلوا يلا. بسم الله. 15 minutes, 15 minutes. We'll be back at, yes, after 15 minutes we'll be back.
Espejo, sí. Mirror. Perfect. No video. Oh. GIF. Animation. Audio? No. Wait a second. Oh, no. Wait a second, I change it somewhere.
I don't care about the privacy.
I will try to change your mind. Is it better? A, B, C, D. One. Perfect.
it's nice, surely it's Mike.
I got that summertime, summertime sadness. Summertime, summertime sadness. Got that summertime, summertime sadness. Oh. I got that summertime, summertime sadness. Summertime, summertime sadness. Got that summertime, summertime sadness. Oh. Kiss me hard before you go. Summertime sadness. I just wanted you to know that, baby, you're the best.
No, I'm so happy now. I will say, oh, oh, hey, hey, oh, Lina, Lina Marouche, Lina Marouche, Lina Mahrouche, Lina Stream, Lina Twitch, Twitch, Lina, Lina Stream, jeux vidéo, Lina Gamer, she's doing games, here with us, she's so happy. Ayman, great guy, he is there, laughing at me. Woo! Ooh, ooh. Let's dance.
I said, can you feel it? This just a little thing we like to call house. House. House.
Allah, Allah. Test. So maybe we'll start now. It will not be easy for Andrei Sitnik. He will talk about what? He will talk about privacy first architecture. It's a problem for me already to do an architecture, not privacy first. So this will be great talk for me because I will learn how to do privacy first architecture. So today we have who? We have Andrei Sitnik with more than 20 years in open source. Andrei Sitnik created a few popular CSS tools. Post CSS, Autoprofixer. He's a great guy. Okay, local first framework and many small libraries with millions of downloads. He's a great guy. He's coming from
Russia.
From Russia, the big country in Europe. From year to year. That's the basic translation of Arabic from here to you know. Mais ça passe. Okay. So I introduce Sitnik. Big applause for him.
Hi everyone. I really believe that modern internet is worse than it was before. That like Silicon Valley really break internet, and we as developer, like Western developers, broke the internet as well. And today I try to explain how we can fix the internet, at least in the part of the privacy. So today I will try to explain why and how developers should care about the privacy of users. And some of people could like start to think like, I don't want to think about the privacy. I don't care. Like, I want to think only about the technologies. I don't want to think about the politics, principles, etc. Can you explain me some framework, some code, etc.? And this is a very good question. Let's speak a little about how software industry related with principles. How many people here use open source, like VS Code, etc., like Chrome? The funny part about open source is not about free. It's not like a free software that you can like download. The idea behind open source is that it's software which you control. Like when you have a MacBook from the Apple, you don't really own the device. You like rent it from the Apple, and Apple can do whatever they want on your machine, and you don't have no idea about what they can do. The idea behind open source is completely political, to be control of your device, to know what software is doing there. So like open source is not about technology, it's about politics. Hacking, it's not about criminal activity to steal money. Hacking is about mistrust the authority. Or like my favorite quote is a quote from the creator of modern cryptography. Like cryptography, we all use it when we ask the website and we have like HTTPS in the domain name, we use encryption. And people who created this, they really believe that this encryption which they are creating, it's not, a technology of fun. That by this technology, they will shape, like they will change the society in the future. And so they created encryptions to make a better society for us, for ourselves. So software industry, people who write code, was always about the politics. It's only the current generation is think only about the money. The funny part is how our society see us as developers. Like right now, society sees us like white guys who are making money. But just a few years ago, like in 90s, society sees us software industry as like different people who like have a principles and defeat them. Okay, but why you should care about, you know, the privacy principles, etc.? First, because like the software you create, it's really change your society. If you will create a software which will track what users are open on their device, your company will use it against you. So you should create a software which like make your world better. The second problem is without the principles, you have a emptiness in your heart. And with principles, it's much funnier to work. You have something like some reasons behind it. But there is a lot of different politics, principles, ideas, and privacy is not the only one. There is no way how you can like prove that privacy is the best one. But I will try. So why privacy is important? First, like there is an idea like I don't care about privacy because you know it's just for advertisement, it's just for the Google to show a better ads for me. But it's not. It's fake. The main problem with privacy is data brokers. Data brokers is a company which buy data from multiple applications, like mobile application, website, etc., accumulate them, combine together, and then sell to very shady clients, not advertisements. It's a completely different type. One example, there is a company called Xmode, it's a data broker, and like they sell data from many applications. For instance, they are buying data from Quran application, from Muslim dating application, from some Craigslist, etc. And all this data, they combine them and sell it to the US military contractor. So it's like very shady and creepy stuff, to be honest. Okay, second question. I don't care about privacy because in my company, we don't sell the data. It stays locally. And here is the problem. It's like, it doesn't work like this. The main problem in this case is data leak, data breaches. It's the idea when if you don't sell your data, some hacker can steal this data from your machine, or it could leak for some other reasons. And we have more and more leaks right now. And if you don't sell your data, it doesn't mean that your data will not be available for the people. It could be leaked. A good example, in Russia, there is a Yandex food delivery. It's like Uber or what is the local application called? Yeah, and it's for delivery of food. And the whole transaction was, all deliveries was leaked. Right now in internet you can find every delivery of the food. And I mean you will have the first and last name, the phone number, the delivery address, and the delivery time for all Russians in 2 years, between the 2 years. So for instance, if right now there is even a nice application with a map, which can even your grandmother can open it and see when and where do you deliver a food. And for instance, if your grandmother suggests you some cake and you say no, grandmother, I don't want it, I already eat, but then you ask her some, I don't know, Chinese food, your grandmother private data. I don't care about privacy because in my application there is only email, name, nothing private. It's again not how it works in reality. Right now there is a problem that we have a data about the same users from the very different application, from a different data leaks. For instance, there is a Quran application, with a direction to the Mecca, to the Kaaba, but it doesn't have name, etc. Only your location and the fact that you are Muslim. But also there is a social app which also use your location, to make pictures, etc. And we can combine this data and track it. And using some data leak, we can combine your email with your real name. And as a result, we will have a proof that you are Muslim, and it's shady stuff again. For instance, how many people use Google Analytics on their website? About half of the websites is using Google Analytics. But Google Analytics doesn't track your website. It tracks all websites. And so if you as a user going from site A to site B to then to C, Google Analytics see it. And as a result, right now Google knows for all of us, all our paths through the internet. Even if some website doesn't use Google Analytics from the previous site will know where you click. And the Google Analytics on the next website will see the referrer. So they have a full pass for all of us by using like this big data. Okay, like you have nothing to hide if you have nothing to fear, yeah? Like, I don't care about privacy because like I have nothing to hide. Unfortunately, there is a people who have something to hide. For instance, one developer from the Twitter, he sold the users' data to Saudi companies. And the main problem that with this data, one girl was imprisoned and another was killed because like they was dissident. So if you don't have something to hide, maybe like some other people have something to hide. And if Twitter did not collect this data, there was nothing to sell. The main problem that Twitter keeps this data. And like it's not only about Saudi Arabia, etc. Like in Netherlands, there is a company who helped Russia to build a face recognition system, and right now Russia uses it against everyone who goes to the street. And it's not only about Russian and like Saudi people, because even in Europe, there was a case when like Spain government asked Proton Mail and Apple to give them a data, to use a law against them. And by this data, they put a person to the jail because he was part of the Catalonia independence movement. And if Proton Mail and Apple did not collect this data, did not put this data to the servers, there was nothing to like take from them from the government. And even if you like, it's not about you, like it's not you don't have some politics behind you. Like if large language model will know your private data, they could change your mind because they can know where to push you. And this is a very like dangerous thing. Okay, but what we can do as a developer with all of this problem? Like right now, internet is a bad place with a lot of pop-ups. Like it's not so nice. You go into a website, you have pop-up, you have like we care about your privacy pop-up, etc. everywhere. But is it like a developer conference here? It's not internet became a worse. It's we made internet a worse place. We are creating pop-ups. So first step, remove GDPR pop-up. Like that pop-up which like, can I take your private data? Yes, no, remove it. But like, we need it by the law. Yes, like the Europe enforces us to use it. Unfortunately, not. In GDPR laws, there is no word pop-up ever. The law tells about simple thing, don't track users. But we as developers, we're so obsessed with the data collection that don't track user, but we understand it as, we will punish users with a pop-up until they will agree to give all data to us. Like, this is a problem. Pop-up is not required by the law. And like our obsession is really strange. Like we so like the data of users that like we cannot understand the simple 3 words. The whole idea of pop-up is a dark design pattern. We show this pop-up so like we interrupt users, so that they have something to do on our website, but because this pop-up they need to know to do something, so they press yes. And we know that this is like a way to like fool them. The real good way to care about GDPR pop-up is to use GDPR compatible analytics. As a result, you don't have any pop-ups. And like when user will sign up or do something, only in this moment, when you need this data, you will ask permission. This is the best way to do it. And analytics without pop-up, GDPR compatible analytics, so it's called like cookieless analytics, they could do a lot. They could do, they can track sources, they can track a campaign, etc. They can not track only like the exact path of the one users, how the exact users are going through the website, because this is tracking by definition. There is a lot of good examples of GDPR compatible analytics. I personally use Plausible, but Matomoto is nice, Posthoc is nice, and Mami is nice. I kindly recommend all of them. There is a lot of them. This is only a small number. There is a much bigger number of the analytics which doesn't need pop-up right now. But like, what if your manager asks you, like your marketing managers, we need the user's data. In reality, unfortunately, in the companies, there is an obsession of the data. Like managers like need the data more and more without any like rational reasons. And there is a very simple question. if a manager will come to you and ask like about the Google Analytics, ask him like what decisions have you made based on the private data in the past year. If there was no decisions, it's just obsession. They don't really need this data. And the main problem with like Google Analytics and all this analytics with the pop-up, that some people, they will press no. And you will not have the data of these users. And as a result, you cannot trust the rest of the data of the people who press yes, because this data is like sometimes not representing correctly the population. Like all people are visiting your website, and people who press yes, this is a different groups of the people. And as a result, you cannot trust the data of only people who press yes. So it's better to use only data, GDPR compatible data, because it will be like distributed from all people. And GDPR is not only in Europe. There is a lot of law in, like, for instance, in Morocco, there is a very similar law, and there is a law in Brazil, in California. So very soon we will have GDPR everywhere, and like it's not about Europe anymore. And I really believe that as a society, as a community, we need to change industry. That yes, people ask from us Google managers, but Google Analytics,